In this lesson, you will translate sentences into equations and translate equations into sentences. So let's try that. 7 times a number squared is 5 times the difference of k and m. So we want to make a variable into a number, and we can pick anything we want, but I do have to write a let statement. So I'm going to say let x equal a number, and I will say 7 times a number squared is equals 5 times the difference of k and m. So look at this and see if this makes sense with the verbal statement that you have here. Okay, let's try another one. 15 times a number subtracted from 80 is 25. So what I'm going to have to do is write another let statement. Let's say I want let y to be a number in this case. 15 times a number subtracted from. So 80 has to be the bigger thing because this is from that. So it's 80 minus is 25. So look at this and see if it makes sense with the verbal here. I would like you now to work on translating some verbal sentences into equations on your sheet. Next we have a problem where we have to solve using a variable. So there are currently 87,000 flights a day in the United States. And how many days will 261,000 flights have occurred in the United States? So here's what I want to know. I want to know days. So I'm going to pick a variable. How about d? So I said let d equal the number of days. And then we have to write an equation. So there are 87,000 flights a day to get 261,000 total flights. Look at this equation and see if it makes sense. So now we will solve for d. So that means I would divide by 87,000 because the inverse of multiplying is dividing. And when you do that, you get d is equal to 3. Now we're almost done. We now have to answer the question. In how many days? Well, that would be 3 days. So if you will look, I have a let statement, I have an equation using a variable, and I have a solution. And that's what you'll do in your notes as well. All right, our first vocabulary here is formula. And a formula is an equation that states a rule for the relationship between certain quantities. Some very popular formulas are an area formula. We have perimeter here, and these are both of a rectangle. There are many formulas that we're going to be working with. This is a sentence that we need to translate into a formula. So the area of a triangle, so we're going to do capital A for area, equals the product of 1/2 the length of the base and the height. So when I write this formula, this should match that verbal. You'll try another one in your notes. Now we have an equation that we need to translate into a sentence, and we could have some differences here, but this looks like 6 times z minus 15 is 45. So I've now made a sentence from the equation. Try this one. Y squared added to the product of 3 and x equals w. Now you try in your notes. The last thing we'll do is to write a problem based on information that we're given. So in this problem, we know that t is going to be the time that Maxine drives. We know that t plus 4 is the time that Tia drives. So we know it takes Tia 4 hours more than Maxine. And then we have this equation. So we have 2 times the Maxine plus 1 times the Tia equals 28 total. And so what we want to do is think about what are we going to ask as our question here. Well, since we have a variable of t, we want to say, how long did Maxine drive? Something like that. So we need to set up the problem, and we'll say Tia takes 4 hours more than Maxine to drive in one turn. And if you wanted to set it up and say, you know, Tia and Maxine are taking turns driving, you could do that to set it up. But we're going to say Tia takes 4 hours more than Maxine to drive in a turn, so I've set this up. And now I will write the equation. Maxine takes 2 turns, and Tia takes 1 on the 28-hour trip. So now I've written this equation. Now we just write the question. How long does Maxine drive in one turn? And like I said earlier, the variable that you're looking for is going to be the question that you'll ask at the end. So you can try the example in your notes. All right, we're good.